is for computation of reliable flows. So the reappraisal of the project will definitely indicate the change required in working system of the scheme according to the monitoring operations of reservoirs could safely and suitably modified. Pench River project complex is selected herein as a case study. The Pench project is a hydroelectric project located at Totladoh and Pench irrigation project which is 23 km downstream of the Totladoh at Navegaon Khairi. Earlier it was named as Kamti Khairi. Pench River is the largest tributary of the Kanhan River which joins the Wainganga in the Godavari basin. It rises from the Satpura hills of Chhindwara district of Madhya Pradesh and it drains the total area about 4,921 km square up to its confluence with the Kanhan River. It is a subsystem of Godavari basin and the total length is about 274 km. The main tributaries of the Pench River are namely Mandhan, Suki, Katmali, Gunnar, Kajri and Kulbhera. Now let us go for earlier planning of the project. This is the hydrological data that we were discussing about. This is the data collected from the 7 rain gauge stations, that is Chhindwara, Junardev, Shivni, Amarwada, Tamia, Mokhed, Deolapar, and the availability of hydrological data is in the form of rainfall data and gauge data. Now the methodology for this particular topic is in the form of system description and the problem identification, literature review, data collection, hydrology and yield studies, rainfall and runoff correlationship, water management studies based on the monsoon. Now the polynomial (2 plus 20.486 P). This expression we got as a linear equation, whereas the top, if you see here, R is equal to minus 596.901 plus 31.398 P plus 0.56 P square. This is the second order equation, whereas the bottommost is the linear equation, that is first degree equation. So these are the runoff series for 80 years that we have compared. So red lines, they indicates the runoffs using first degree equation. Then green color is used for second degree equation, and the black color is used for Thomas firing model. So this is the rainfall on abscissa, and runoff in million meter cube, they are expressed in on ordinates. Then the plot of first degree and second degree curves, they are expressed in the form of graphical representation. So red colors or the red points, they indicate the first degree equations, and runoff, that is black color, that black triangles, they indicate the second degree equation. Now these are the generated polynomial equations that we obtained from different record lengths, that is 46 years, then 66 years and 80 years. And degree of equation we obtained as first degree equation, second degree equation, third degree equation, and the log-log correlation. For 66 years, same thing we repeated here, first degree, second degree, third degree, and log-log. And similarly for 80 years also. So the equations are expressed like this way: first degree equation, second degree equation, third degree equation, and log-log correlation for 46 years. Then first degree equation, second, third, and log-log correlation for 66 years, and first degree, second degree, third degree, and fourth degree for 80 years of rainfall record length. Similarly, for all the values, we obtain the correlation coefficient here. So they are expressed for these are the correlation coefficient for the 46 years, first degree, second degree, third degree, and log-log correlation. Then correlation for the 66 years of rainfall, and the correlation coefficient for the 80 years of rainfall for different orders of the polynomial. Similarly, determination coefficients are also obtained in the same way. So then these are the annual runoffs obtained for 46 years, then 66 years and 80 years. So all these representation for different series, they are comparative here. So first degree equation, second degree equation, third degree equation, and log-log correlationship. So this is for the 46 years, then 66 years, and 80 years. See here, these are the rainfall records, that is for 46 years, then 66 years and 80 years. And on the ordinates, you will find the runoff values in million meter cube. Similarly, this is graphical representation, the graphical comparison of different order of equations or polynomial equations, that is for record length for the 46 years. So here R is equal to minus 338.38 plus 20.486 P. R is equal to for first degree equation, R is equal to minus 596.901 plus 31.338 plus 0.56 P square, that is for the second degree equation. R is equal to 790.78 minus 10.877 P plus 0.276 P square minus 0.008 P cube. This is for the third degree equation, and log R is equal to 0.770 log P plus 0.1664. Here R values are represent the runoff in million meter cube, and P values are represents the precipitation or the rainfall in centimeters. Now as we go on increasing the degrees of polynomial curve, what will happen here? So as soon as let us say these coefficients 0.008 P cube, for fourth order equation this gets reduced, then fifth order it gets again reduced. So it will leads to the 0, 0, 0. So it is not desirable to follow the for the fourth degree order, fifth degree order. So it is always better to have up to third degree equation, because later on the series gets converged. So same practice we adopted here, same procedure we adopted here for 66 years. So R is equal to minus 456.335 plus 21.502 P first degree equation, R is equal to 970.32 plus 30.124 P minus 0.0345 P square for second degree equation. Then R is equal to 915.880 minus 17.038 P plus 0.3446 P square minus 0.001 P cube for third degree equation, and the log R is equal to 0.682 log P plus 1.269 for log correlationship. This is for obtained for the 66 year rainfall values, and these are the runoff values in million meter cube. So this is obtained for the 80 years of the rainfall series or the 80 years of the data series. So these are the all again rainfalls values, and these are all the runoff values expressed in terms of million meter cube. So these are the first degree equation, second degree equation, third degree equation, and the log correlationship. So accordingly we obtain this 80 years of the record length, and all the four equations for based on the polynomials. So this is the record length for the 80 years that we obtained, and the reliability in percentage that we obtained. Why we take the record length for the 80 years? We found in the my previous slide, that is these values, the correlation. We focus on the correlationship. So correlationship for the 80 years and the first degree equation found a promising value. So therefore we have chosen the first degree equation for 80 years as the database for further analysis. So these are the values. The reliability are expressed in the percentage. Reliability is also known as the dependable yield, and these are the reliability expressed in terms of the percentage: 50, 55, 60, 65, 70, 75, 80, 85 and 90 at in the interval of. These are the first degree equation values obtained by first degree equation, the values of runoff in million meter cube by second degree equation, then third degree equation, and the log correlationship. So these values are tabulated in this table form, and for different dependable yields we use these values for further analysis. So 75% we considered as the normal yield or the normal dependable yield, and 90% we considered as the critical year of rainfall, that is the critical yield. So 75% normal yield we design for the irrigation projects, whereas the 90% dependable yield we design for the hydroelectric consumption and hydroelectric projects that we considered here. So here, and 50% is a promising year of rainfall or the very good year of rainfall. 75% dependable yield we consider the normal year of rainfall, and the 90% we consider the critical year of rainfall. So these are the reliabilities are expressed in the percentage, and their values are expressed in terms of the runoff for the further analysis. Now what is reliability or the dependable yield? Let us say this 50%. What do you mean by 50%? 50% means this value is obtained for 50 times in every 100. Similarly here 75% normal year of rainfall. So this 1655.424 million meter cube values obtained for 75 times in every 100 years. And similarly here 90 years, that is 1413.235, this value obtained for 90 times in every 100. So these are the regarding all the reliability of the flows and record length for the 80 years, and the first degree equation values of the runoffs are expressed in the table form. And these values are used for the further analysis for design of the irrigation projects, monitoring of the reservoirs, and optimization of the cropping pattern that we will discuss in the next lecture of series. Please do subscribe my channel if you like this video. Thank you.